Assalamualaikum and hi. My name is Siti Nur Ala binti Ramdan and I am going to talk about introduction. So, what is UV-vis spectroscopy? UV-vis spectroscopy is called as UV visible spectrum or commonly known as UV-vis. It absorbs organic compounds such as benzene, inorganic species like transition metals, and charge transfer, which is a combination in which one species accepts electrons while the other one donates them, which is donates the electron. UV visible spectroscopy frequently used to calculate the concentration of a chemical in a solution or to detect the functional groups that are present in the molecule. Different wavelengths of light are used to measure how much of a sample absorbs light, and the resulting data is represented as a spectrum. So, for the principle of UV-vis spectroscopy, firstly, chemical substance that absorbs UV or ultraviolet or visible light produce a different spectra at the end of the result. For the second principle is molecule that absorb the electromagnetic radiation or EMR in the range will cause transitions between electronic energy levels in the UV-vis spectroscopy. As you can see the picture below, it is a picture of electron behaving from ground state to being in an excited state. The electron in the substance go through an excitation process when electromagnetic radiation, which is the photon, is being absorbed. As a result, the electron move rapidly from their ground state, which is from a condition with a little amount of energy, to the excited state, where an energy state with a relatively large amount of energy associated with it. So, for the third principle is that molecules that contain vibrational and rotational sublevels also has electrical levels. And lastly, the band spectra will be produced by transitions between these chemicals' energy levels.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Hazoni binti Masya. My metric number is 2020-827182. Now, I'm going to explain to you about the methodology of this case study. For the instrument, we use UV-vis spectrometer, which is Perkin Elmer Lambda 35. The double beam spectrophotometer having the range between 119 to 1000 nanometer and bandwidth 0.4 to 4 nanometer. For the pH determination, we use beverage pH were determined by using Sartorius pH meter. Next, for the preparation of stock solution, we use all glassware were washed with distilled water. Then, the glassware were dried in oven at 105 degrees Celsius. Then, a 10,000 ppm stock standard of caffeine was prepared by dissolving chloride in 200 mm volumetric flask. Next is the preparation of standard solution. Working standard were prepared by pipetting 0.1, 0.2, 0.3, 0.4 and 0.5 milliliter per respectively. Aliquots of stock standard solution into a separate volumetric flask of 100 mm and dilute it with carbon tetrachloride and forms a 10, 20, 30, 40 and 50 mg per liter standard solution. The absorbance of each solution was measured at absorption maximum of 2000 and 2070 nanometer using 10 mm quartz cuvette. The last one is a caffeine extraction procedure. First, the brand of soft and energy drink were taken by different shop. Second, then the sodium carbonate solution is prepared by dissolving 20 grams of sodium carbonate into distilled water in 25 ml of volumetric flask. Then, separating funnel was taken and adjusted in the stands beakers. Then, 5 ml of drink sample was thrown in the separating funnel by addition of distilled water and add 1 ml of sodium carbonate solution in the separating funnel and adding 20 ml of carbon tetrachloride in it. Then, the caffeine was extracted by inverting funnel at least 3 times, venting the funnel after each inversion. Next, the non-aqueous carbon tetrachloride layer was removed to clean a 50 ml volumetric flask. Another 20 ml portion of carbon tetrachloride was added to aqueous solution. Inspirating funnel and extraction procedure was repeated twice and carbon tetrachloride layer combined. This procedure was repeated to all drink sample and the absorbance of resulting solution was measured on the UV spectrophotometer at 270 nanometer using 10 mm quartz cuvette.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Idina binti Muhammad Fazil. So today I am going to make a presentation for discussion energy drinks. Based on the data obtained for energy drinks, the pH range for energy drinks are between 2.85 until 3.28. For energy drink 4, the pH is measured is 2.5, which is energy drink 4 has the highest acidic and among the energy drinks. Energy drink 1 with pH 3.28, which is it is less acidic than the other energy drinks. So for the total of energy drink, we have 4 energy drink. Energy drink 4 is the most acidic, followed by energy drink 3, energy drink 2, and energy drink 1 with the pH less acidic. So for the caffeine concentration, the highest caffeine concentration found in energy drink 2, which is 101.705 ppm. Energy drink 2 has the highest concentration of caffeine. This can be harmful for the consumer to drink because of the high concentration of caffeine. So energy drink 2 must be discontinued. Next, we move to lowest concentration of caffeine, which is in energy drink 4. It is measured to be 32.05 ppm, which is safe for the consumer to drink the energy drink because of the low caffeine concentration. Next, we look at the data obtained for energy drink 1, 2, 3, and 4 for the mean, variance, and standard deviation value. So the highest mean value is energy drink 2 with 101.705, and for the variance, highest variance value is energy drink 3, 29.87645, as well as the standard deviation reading for energy drink 3, also the highest, which is 5.6594. So based on the data obtained, we can see that energy drink 2 should be discontinued because of the high concentration of caffeine. It can be harmful for the consumer if they keep drinking the energy drink 2 because of the high concentration of caffeine. And the lowest concentration of caffeine is energy drink 4, which is 32.050.
Next, my name is Nur Shazrin binti Shuaimi, and I'm gonna discuss about soft drink. So the main purpose of this research is to the caffeine level in soft and energy drinks either is high or low than the recommended value by the FDA. All of the soft drinks have pH range between 2.29 until 3.02. In addition, the ideal or the best pH of the mouse range around 6.5 until 7.5, which very neutral. Next, a pH 5.5 is considered to be a threshold level for the development of the dental decay. Both of soft drink and sport drinks have been proved to have a pH range between 2.5 and 3.5. When the pH falls below the crucial 5.5 threshold for a extended period of time and on a regular basis, demineralization of a dental enamel will happen more quickly. In addition, all soft drinks are acidic, such as cola drink, that make our bodies lack oxygen. So, as you can see on the slide, brand 2 has a highest pH value, which 3.02 compared to all soft drink sample, and then less acidic among all soft drink. Brand 5 lowest pH 2.29 compared to all soft drink sample, and then meaning that brand 5 are more acidic among other sample. Next is the caffeine concentration in soft drink are ranged between 10.69 until 42.17 ppm. Brand 5 has the highest caffeine concentration, which is 42.17 ppm, and has lowest pH value among others. Thus, it is most acidic compared to all soft drink. The strongest central nervous system stimulant and has been discontinued in the market. And while brand 3 has the lowest concentration of caffeine, which is 10.69 ppm, and pH value are high, thus meaning that this brand have less acidity compared to others. Brand 3 also weak central nervous system stimulant. Moreover, the US Food and Drug Administration (FDA) in 2006 said that limit maximum amount of caffeine in soft drink is 200 ppm in 6 mg. Therefore, caffeine content allowed in soft drink may be 30 to 70 mg in 355 ml.
Hi, my name is Siti Nabila, and I will continue the discussion part for comparison of label and calculated concentration for energy drinks and soft drinks. So this table shows the label and calculated concentration of energy drinks. Energy drinks once concentration was labeled as being 300 mg per 250 ml and was actually calculated to be 299.95 mg per 250 ml. The energy drink is the first brand of ginseng to have ingredients that lower tension, ease stress, and boost metabolism. It is produced by King Beverage, and the label concentration was 450 ppm per 250 ml, while the calculated caffeine contained is 508.5 mg per 250 ml. Energy drink 3 label concentration of 300 mg per 250 ml, making it less caffeinated overall. So for the energy drinks 4, caffeine content was less than what was indicated on the label, which is 200 mg of caffeine per 500 ml as opposed to 160.27 mg. Next, for the soft drinks, the brand 1 had been concentration was 188 ppm per 250 ml, and then the brand 2 is 61.72 ppm per 250 ml concentration. And then for the brand 3 had label concentration was 106.9 ppm per 500 ml, and for the brand 4 calculated 95.55 ppm per 250 ml, so it is less than its label caffeine content amount. Next, for the brand 5 had label concentration was 210.85 ppm per 250 ml, which is the higher concentration between the others of brand, which is brand 1, brand 2, brand 3, and brand 4. Next, we move to this graph. So as you can see from this graph, this is the graph of comparison label and calculated concentration for energy drinks and soft drinks. So from this, we know that the brand 5 for the soft drinks has the higher concentration of caffeine, which is 210.85 ppm per 250 ml, while the lowest concentration for soft drink is brand 2, which is 61.72 ppm per 200 ml. So for the energy drinks, the highest concentration is energy drinks 2, which the label concentration was 450 ppm per 250 ml, while the calculated caffeine content is 508.5 mg per 250 ml, and the lowest concentration for energy drink is energy drinks 4, which is 200 mg of caffeine per 500 ml, as opposed to 160.27 mg. So I think that's all from me. Thank you.